Hello students, continuing with our previous class, we were talking about types of learning. So today we will talk about reinforcement learning. So in reinforcement learning, we talk about a task. Our task is to learn how to behave successfully to achieve a goal while interacting with an external environment. To understand this better, let's look at this diagram here. So I have an agent which is able to take actions. And there is a space defined for all the actions possible by capital A, and every action that I take small a belongs to this capital A. Similarly, I have a set of states and capital S, and every state that I am in, it belongs to that's the small s belongs to this capital S. And from the environment, once I take an action, I am in a particular state, I get back a reward R. And the new state also, because I have a new state S dash, so I am transitioning from S to S dash by the action A, and this also belongs to the S, capital S class. So there are states here of capital A, capital S, and I have to choose my state according to the action that I take. So to be able to understand this better, suppose I have a game of chess and I am playing from the white side. So all my pieces could be moved in certain ways according to whatever piece that I move by the rules of chess, and every action that I take will take it to a new state, and that state ST will also belong to the superset of all the states possible for that particular game. So what am I doing? I, as an agent, am performing an action in the environment is this chessboard, and I am moving into another state, and for that state I am getting a reward. So there is a condition that for every action that I take, I get a reward or I get a penalty. So ultimately I am trying to maximize my rewards by learning to play better. So as and when, it's like normally what we do is, as we keep playing, we understand the moves of the other person, and I am able to understand which move will get me a better reward. So as we keep playing, we understand the rules better, and we understand the gameplay better, and we get better at playing chess. So basically, what is our model? In reinforcement learning, there is an agent that interacts with a certain environment, thus changing its state, and receives a reward or penalties for its input. It is not told which action is the correct one to achieve its goal, because it really doesn't know about it. Its goal is to find patterns of actions by trying them all and comparing the results that yield the most reward points. So ultimately, with every gameplay, I am getting more intelligent, I am understanding how to play better, and the ultimate aim is to get maximum reward points. Now, one of the key features of RL is that the agent's action might not affect the immediate state. So obviously, like in chess, I make a move, immediately I may not lose my piece. In the subsequent plays, I might understand that okay, this is the move which was wrong, and this is where I started falling behind. So sometimes the machine doesn't learn whether an action is effective until much later in this episode. So to sum up, reinforcement learning is a type of machine learning in which the machine is required to determine the ideal behavior within a specific context. So whatever my environment is, whatever my agent is, according to that I have a specific context in order to maximize its rewards. It works on the rewards and punishment principle, which means that for any decision which the machine makes, it will either be rewarded or punished. Thus, it will understand whether or not the decision was correct. This is how the machine will learn to take the correct decisions to maximize the reward in the long run. So there are lots of algorithms which work on this principle: Q-learning, temporal difference learning, and deep reinforcement learning, which we will talk about when we move specifically onto the reinforcement learning algorithms. So this has lots and lots of applications. So you know about these automatic cars, self-driving cars. They also start learning by reinforcement. They keep interacting with the space environment, and they select action based on the past experiences that they take to be able to make choices. Now looking at the applications of reinforcement learning. Now robotics has applications. So RL can be used for high dimensional control problems as well as various industrial applications. Google, for example, has been able to cut its energy consumption by 50% after implementing DeepMind's technologies. And there are lots of innovative startups in this space which are basically using deep reinforcement learning for efficient machine and equipment tuning. Text mining, so all of you must have heard about ChatGPT, which is basically able to write beautiful content for you. So it started with Salesforce, where this company was able to do text summarization. Lots and lots of applications like ChatGPT, Jarvis and all are available for text mining. Then trade execution. So JP Morgan has started using reinforcement learning to be able to understand when to offload huge stakes without creating market swings. Then in healthcare, a lot of applications are there where you are kind of looking at medical dosing, optimization of treatment policies. So wherever I am able to learn with repeated learning, there are applications of RL. So I hope the concept is clear. I will continue in the next class. Thank you.